Okay, often confusing problems, and reason I say that is solving an inequality like this, someone wonder what's the question? Once you solve the when is the natural log greater than or equal to the cube root of x? And I'm going to say a visual approach is probably the first way to go about it. All right, so let's go visual approach in the problem. I'm going to open up an application called Grapher, and what I want to graph out both the natural log and I want to graph out the cube root of x. All right, now I'm looking at it, and I notice that the cube root of x is greater than natural log. Certainly, when I'm looking at this image over here, that looks to be the case over here. All right, I don't see any issues where the natural log is greater than the cube root function. But what I want to do is I want to kind of zoom out. And I notice that right over here, the natural log overpowered. That's the green curve, by the way, overpowered the cube root function. And you might say, oh, that's when it happens, and forever onward, it's going to remain above that. But I'm going to just keep zooming out a little bit and looking at this over here. They seem to be getting pretty close over here, but I'm so far away now, I really can't see what's going on. So what I'm going to do is I'm going to zoom in this region over here. And what I'm starting to realize is that that green curve does go above the cubic function. This is the natural log, by the way. But then about over here, it seems to go below it, all right? So what I'm going to do is I'm going to zoom into that region now. Let me see if I can do that. All right, so I'm seeing a point of intersection over here. I'm seeing a point of intersection over here. Now, granted, what I can do now is find the points of intersection using the software. They did say use Newton's method, but I'm going to find intersection. Now, what I'm going to do is I need to give it an approximate value over here. And looking at it, I'm going to say over here, it looks around 6. I'll say, okay. Whoops, I think I made a mistake there. Let me do that again. Oh, yeah, I'm sorry, I closed it out. So it says the x is really 6.4056. Let me go back to my notes. And I want to point out we did do the student-induced method, and I'll go through that as well, by the way, but relatively the same number, all right? Now, what I want to do is I want to do a different approximation. I'm going to look back at the graph over here, and look at this point over here. I'm going to say it's somewhere around 90, all right? And let me, you know what, I don't need to go back to my notes yet. Let me find a point of intersection now. And again, you should be using software. Whoops, didn't mean to do that. My guess is around 90. And what does it give me? About 93.354. And by the way, we'll get these numbers over here. I'm just scrolling over my notes, by the way. Again, it does a pretty good job. I'm not sure how it does that, but it does a pretty good job of it. It really does. All right, let me close that out. I'm done looking at this over here. And the next thing I want to do is, the first thing I did was I did the visual. All right, that's the first thing I did. Now, other things I want to do is I want to show that the cube root function, certainly in the long run, becomes much larger than the natural log function. And that's something you may be aware of by using limits and L'Hopital's rule. And maybe I'll go through that too. But I do want to go to the SAGE. Thank you.